Our subject is biophysics, so we discuss about physics of enzyme substrate interaction. The physical significance of the enzyme catalyze is primarily due to the role played by the globule, whose size is an order of the magnitude larger than the size of the substrate. Naturally, equation arises as to the cause for the insufficient of the such as a system in the course of a chemical conversion in aqueous solution at the normal pressure and physiological temperature. Undoubtedly, electrostatics interactions are of the importance for enzymic catalysis, especially in the case of ionic reaction. Lysozyme is in this sense a specific enzyme, and the calculation made can't be regarded as being of universal value. The protein globule is a dynamic system. There have been made a number of interesting attempts at a physical interpretation of the behavior of the such a system upon its interaction with the substrate. We shall have the less made a simple estimate of the acceleration of the reaction based on the assumption of the transformation of the substance energy to the energy of the enzyme substrate complex. Let the length of the stretches substrate molecule to be low, and the length of the enzyme cavity into which the substrate fits. The changes in the length of the substrate molecule and the enzyme are respectively equal to the x and y, then the molecule and the enzyme are respectively equal to x and y, then x plus y is equal to L minus L0. And the condition for the equality of the elastic forces has the form Ksx is equal to Key, and where Ks and Ke are the coefficient of the elasticity of the substrate and enzyme, we find x is equal to L minus L0 upon 1 plus Ks upon Ke, and y is equal to Ks upon Ke into L minus L0 upon K plus Ks upon Ke. The state model, so called rake model, considered above the statics one. If we assume that the elastic system is a dynamic one and there arises a resonance of the vibration of the substrate and an enzyme molecules, then the same acceleration will be attained by an average elastic energy 4 times lower than the static case, since pulsation periodically double the vibrational amplitude. This specular model deals with the vibration of atomic nucleus that arise as a result of the formation of an enzyme substrate complex. These interaction is the accompanied by changes in the state of the electron shell of the substrate and atomic groups of the active sites. Second, we talk about electronic conformational interaction. So to understand the nature of the electronic conformation interaction, it is help to make use to spectacular model of the interaction between electrons and atomic nuclei. Electrons in potential box with the infinitely high mobile walls. A set of atomic nucleus of a molecule or its functional part is modeled by means such a box. Electrons are placed in the box like to an electron occupancy and level. The possible values of the energy at the electron inside in the box are easily calculated on the basis of the concept of de Broglie standing waves with the nodes at the walls. If the width of the box is L, other standing waves have wavelength this equal to lambda is equal to 2l upon n. There is n is equal to 1 2 3. So here's like this box, and there is a graph to understand to this. And then the velocity of the an electron in the box is founded from the de Broglie relation, the electron mass. There is a formula, and then inside the box the energy of the electron is equal to its kinetic energy. Then there is this formula. Then the electron extra a pressure on the valve, which is given by is equal to d upon dl is equal to n square h square upon 4 me l cube. The overall result of the electronic conformational interaction consists in the bit electron rearrangement during the course of an enzymatic reaction is associated with the changes in conformation of the protein. This situation can be described in the language of solid state physics. The displacement of the electron or electron density in a macromolecule cases in long wave forms, and this electron plus the deformation of the macromolecule is found to be similar to the polaron. We shall call such as a system the conformal. So there is an important object for the study of electronic conformational interaction are metal enzymic, in particular enzymes whose cofactors are ions of transmission metals.